Greetings, everybody. Welcome to Macro Talk 2. It is Thursday. I think it's Thursday, and I think it's March. January, February, March. Yeah. March I'll guess here, 13th. Thursday the 13th. Lucky day. How's everybody doing? We've got a lot to cover today, a lot to talk about. It'll probably be the last live stream that I take up talking about DIY projects, but this is a very specific project, two projects actually, that I want to have a record of this so that anybody who downloads the files to their computer and uses them to print one of these devices might want to know how to put it together. So I thought I would cover that today, and then it'll be a video and people can check it out in the future if they need it. So that's what we're talking about. Before I forget, we have a Pazoom on Saturday. If you are a Patreon member, a member of my Patreon supporter group, then you're a fine person, first off. And second, every other weekend, every other Saturday in the morning from 10 until noon, we have a face-to-face get-together where we sit around and chit-chat about this, that, and the other. We compare notes and look at rigs and talk about new cameras and look at macro pictures and just have a rare old time. I thoroughly enjoy it. We do it, like I say, every 2 weeks. If you're not a member of Patreon, you are missing out on something very much fun and educational. That was not an English sentence that I just used. I've been talking to ChatGPT too much. So, would you like to hear about my sinus infection? No? Okay, all right. I didn't even have to do a show of hands. Everybody said no. It's miserable. It is absolutely miserable, and I won't describe it any further because it'll put you off your lunch. So, what we're talking about today are two things that I have made that I think might be useful to you. One is a reimagining of the whole cross-polarization platform for crystal photography. And you know what? I'm going to show you what we're going to be working on. There's going to be a lot of camera swapping around and fidgeting because I've got too many cameras and don't know which one is pointed where. So just bear with me for just a moment. So sorry about that. I just made that scene a minute ago and I didn't have a microphone on it. I do apologize. Hopefully you can hear me now. So this is the thing that we're going to be making, and the files for it, I have yet to post them, but there's a couple of things I want to tell you about that when we get to it. So this is a vitamin C crystal somewhere in there that you would be able to see quite well if you were using your eyes and not an iPhone. Yeah, I can't get the exposure down far enough, but it's in there and it looks fantastic because it's birefringent. So there you go. That's what we're going to be talking about. That's what we're going to be making, and I'm just going to walk you through the steps so that you know exactly what you have to do if you're going to try to make one of these. The files are going to be free. The print files, the G-code files. If you want the Fusion files, the Fusion 360 STL files, you are going to need to get them through Patreon. That's the only place I'm going to be putting the whole 3D project, mainly because it's such a big mess. I don't want to be responsible for people going mad trying to figure it out. Let me show you what it all contains. It's this is the final product. The thing that we're going to be making today, and it's pretty straightforward when you look at it like that. But when you look at it like, I don't know, like this, hang on, let me get out of that. So when you look at it in pieces, you'll see it's got a lot going on inside, and yeah, a lot of different bits and parts. And we're going to learn how to put it together today so that you know how to do it. But I'm going to make these files available to my Patreon supporters. That's in case they want to modify it. If they want to do something different than what I've done, they're more than happy to do that. So this will be available to the Patreon folks later today. The G-code files will be available on my website and on Discord later today. And all you have to do with those, there are 9 separate things that you would need to print. I think they might be visible in the Prusa slicer. No, they're not. I got rid of all the ones that I'd already printed. But each the folder contains 9 separate files, so you print the pieces one at a time, unless you have a massive printer, and then I guess you can do them all together. But yeah, one at a time, and don't be getting on me for my choices when it comes to print settings. I ended up with these print settings because I was having problems with some of the fine details, and I've got lots of supports, organic supports on these. So you can redo the G-code if you want, but these work, and you'll see the parts today. So they'll be available today. Also over on Patreon, but not anywhere else. Hang on a sec. All of the hardware that you need, all of the bits and pieces that you need are going to be listed. Now, I'm going to list those on my website and on Discord and on Patreon. But if you want to take advantage of a special offer that I'm giving to my Patreon folks, then you'll need to do something about that, like join Patreon. What I'm going to do for them is I'm going to put together all of the parts in a kit that I will sell to them at whatever the kit costs me to make. And it's going to be, because I buy all this stuff in bulk, I buy loads and loads of the parts, and I'll split them up. I'll put them in sets for one polarizer, and I'll mail them to you, and it'll be just what it costs me to do that. So it'll be way less than if you tried to do it yourself, because you'd have to order bags of things. And I can't do that for everybody, because it's just too many people might want this thing, and then it would drive me crazy. Another thing I'm doing for the Patreon folks is if they just don't want to mess with this, but they want one of these polarizers, they can buy one. And yeah, again, they take hours to make, and yeah, they take me hours to make and a day to print. So that'll just be for Patreon too. So now you know what the deal is, but the files will be available for you later today. If you have any questions, put them in the chat if you would. Now, let's get on with today's thing, because what we have to do is put together this whole shebang, and I have not done any of it. I saved one of them. I put together, as you can see, a few of them, and they're the ones that are owed to people, the winners of the competition in December, for example. But yeah, the one we're putting together today has had almost nothing done to it. I accidentally did the inserts, but don't worry about that, because I've got something else I'll put an insert in to show you how that works. So I'm going to tell you everything you need, all the parts you need to order will be in that list, but I'll show them to you right now. So my phone has suddenly become upside down. I do not understand how this thing keeps doing that. Watch, it'll go upside down again just as soon as I flip it over there. Maybe not. Okay, great. So here we are. Let me show you. Let's get rid of the finished one, because that's just going to get in the way. I only put it on a bendy arm to show you how extremely cool it is. This is what you would use if you wanted to position it in front of your camera in the upright orientation to take pictures. Quite clever, I thought. Let me put that over there. These things, the folks that are buying them, they're going to come with a power supply and everything, and it'll all be put together. So that'll be fantastic. By the way, the other thing we're talking about, the microscope focus block motor mechanism, that's going to be a very quick part for this. So if it looks like we're running out of time, don't worry about it. Okay, so the printed parts, the core of this whole thing consists of the base. That's the base, which like I say, accidentally already put the inserts in, 3 of them. 1 for the bendy arm, 2 for the thing that holds it all together. And this is printed in one piece. There is an insert that goes into it right here. This holds the diffuser and the first polarizer. And because you don't need to touch that, you can't touch it. It's down inside. You'd have to take it apart to do so. Then there's an empty ring right here. These are called the bodies, by the way, the bodies of the levels. So this is, and there's even, if you look closely, there's a number there. So you know what number it is. And inside it is another thing that I call a cassette. So every level has a cassette. This is level 2 for your wave plate, your retarder. And this is the cassette that it goes in. I don't have any, so I'm not putting them in, but I'll put this layer in so that you can add it if you need it or want it. The next layer is the specimen layer, or the subject layer. See how this has got different shaped nubbins there? 1 square one there and 2 round ones there. That's so that you can only put this thing in one direction and it locks in place. This was another genius idea I had in my sleep as I was designing this. This is the cassette, and it's different because it has room for a slide, either a large 50 by 75 or a small 25 by 75 glass slide that your crystals are on. So you'll slot it in there, drop it in, and you won't access that again until you take the lid off, which is the only thing I don't like about this, is you have to disassemble the top layer to change your slide, but that's okay. Top layer also has nubbins so it stays oriented correctly, is another body containing another cassette. This cassette is going to contain the analyzer, the second polarizing filter, and another linear polarizer will go right into this, and I'll even show you how to put that in, and that will sit in here. Now if you look at all of these cassettes, they all have one thing in common. They have little holes all the way around their perimeter. There's a reason for that. The reason is that each of them can be seen through these little windows. The nubbins can be. And that is so that you can take a pen or a pencil or a pointy anything, and you can change the orientation of your polarizer or your subject or your wave plate if you use one. And they're the only 3 things you'd ever need to change. So that's very cool. And I like this. Even though people I asked about it said, no, it's a terrible idea, I still like it because it's very easy and very, it gets rid of all the doors and other things that could break on this. And it's just very easy to do. And I've been using it now for a few days and I absolutely love it. The top piece, the 9th print you have to make, is the cap, layer number 5. It holds everything together and it screws in with, this is the one major mistake I made in doing this, was I bought these little thumb screws with too long of a screw on it, because it takes half an hour to screw this in. But it goes right into the insert that I put there, and you just have to screw it down, and there are 2 of them, and when you get it all the way down, it just holds everything together like that, and nothing can slip out or fall. That's it. That's all we got to do. So let me show you the particular steps that we have to do. We'll deal first with the electronic stuff down at the bottom. We can get rid of all of those layers. There are 3 components. Now, there are actually more than 3. You'll buy these separately. You'll buy the light, the cable, the socket that has no wires on it, so you'll have to buy some wires, and you'll cut them to size. You'll have to solder them onto the plug, and then there'll be a switch which does come with wires, because I bought them that way. That's what the plugs look like. buy them. Oh, sorry about that. This may happen a lot because I don't know why it's happening. Let's see. Okay. That wasn't supposed to happen. Hold on just a second, chaps. Okay. You know what I might do is try switching to the slightly more predictable other camera. Let me do that. There you go. Yeah, that will work. Yes. So we'll do that, and we'll just retire the phone for the time being. I'll fire it up again if we need it. So, let me get that out of the way. All right. So here we are. I just knocked over my hot glue gun. You're going to need, oh yeah, I forgot. You're going to need a hot glue gun. I highly recommend this one because I spent too much money on it, and I want you to have to spend too much money on it too. It's a Romeck. It's very hard to figure out how to do that. There you go, Romeck. I got some black glue because I thought that would be less obtrusive, but it's, yeah, it doesn't make any difference. And you may need, well, you will need a soldering iron. I've got one over here. I can't show it to, well, no, I'm not going to risk that. I'll show it to you in a minute. It's over here. We need that to put these components together. And yeah, this is the switch that comes with the wires, and it comes with a bunch of hardware screwed onto the post. So the first thing we're going to do to get this show on the road is turn on the hot glue gun, because we're going to use it in a minute. And we will, and this is another thing I do not want you to be giving me any flack about, because I'm not particularly good at this stuff. I'm just enthusiastic about it. So there's probably a better way to do everything that I'm getting ready to do. But keep it to yourself. All right, so the switch goes through the switch hole, which is just the right size for it. Okay, and it'll fit down in there in the little cavity that I made. You'll pop the toothy looking washer thing over the knob, and then you'll put a nut on it and try to tighten it. It's quite difficult because there's things in the way of your fingers. Anyway, eventually, you don't need a spanner. Just use some pliers for this. Just chat amongst yourselves. There's going to be lots of these interludes while I try to do things that are beyond my capability. Now, it's important to tighten this because, well, because you don't want it to fall out. There we are. I think it is already tight. Let me just give it one more twist. They make a thing called a spanner, but I don't have one handy. There you go. That's nice and tight. So that's going to be the on-off switch. Let's put the plug in now. The plug, I had to put wires on it. And notice also I put little sleeves of shrink wrap tubing. I buy this marine 3-to-1 stuff that shrinks down 3 times because it makes a really nice tight junction on there. So we're going to need to put 2 of them on, one on each piece of wire, so we can cover up the joins we're going to make. And then we'll pop this in the plug hole, which is right there, the other hole that's on the thing. Now, this also is supposed to have a nut that goes on the inside, and I made it big enough for the nut to go on, but the nut's terrible and it just slips off all the time. So I came up with a much more glue intensive way of doing this, and I just put a blob of hot glue down in there and it seems to hold it just fine. So we're going to do that right now. That's why I turned that gun on. I'm just going to put a blob right around. Oh, I don't think it's melty enough yet. There it is. So one big blob of this, and then nothing's going anywhere. We don't want those heat shrink tubes to get the hot glue on them. So just by putting that one blob on there, when that hardens, this plug's not moving. So that's good. And we'll be using more of this hot glue on other parts of this build. So I'm going to leave it turned on. Yeah, it's good to kind of hold it so that it doesn't stray while it sets, but it takes a minute to do. All right, the other piece that you're going to buy is this chip on board LED panel thing. It's very, very bright. It's a 12-volt light, and that's why we need all these plugs and switches. So to connect this one, it's called a G4 plug, and it's all listed in the list of parts. You just plug it in like thusly. It's got 2 holes and 2 wires, and it's non-polar. You can plug it in either way. In other words, it's got a thingy-majig that protects it if you do it the wrong way. And seeing as I don't know what the right way is, don't worry about it. So plug that in there. And I've got 1 long wire and 1 short wire. That's just, I don't know why I did that. It just made it easier to get the thing to attach. Now, the print has been done in a genius way to allow this to go in very easily and hold the panel exactly where it needs to be underneath all the layers and completely flat with a little air gap. It doesn't get hot. I tested it. So what we're going to do is take a hot glue gun and we're going to put a little blob underneath on one edge just to kind of hold this thing where it needs to be. That's not absolutely vital, but I find if you don't do that, it kind of can tip a tiny bit up the way. So you just let that sit there for a minute and that will be there permanently. And then I'm going to put another blob right where the socket, the G4 socket, goes through the little bridge that I made for it. The old ones had a complete tunnel that this thing went through, and if you didn't get it right, you could never get them in. This just works better, and in just a few moments this whole thing will be set up and solid. All these parts will be permanently mounted. Oh dear, I should have held that red plug. See, I've got a little gap around it. I might add a little more glue, or I'll just not worry about it, because it's not going to go anywhere. It's just a little bit pushed out. I'm a bit too much of a perfectionist to accept that lousy outcome. So I'll put a blob of glue down in there. There we are. This time I will hold it. So what happens is that the current, you're going to put your 12-volt plug. It's one of these things. One of these. It goes to a wall wart that puts out 12 volts and 2 amps. It's included with the kit, and it's included if you buy one of these. Otherwise, you're going to need one yourself to make it work. Now, the positive is connected to the red wire, and the negative is connected to the black. Now, what we need to, it doesn't really make any difference because of the non-polarity of the light, but what we're going to do is we're going to connect the red, the power coming in, to the power going into this switch. So those two will be connected together. And then this is the power to the light, and that's going to come around and connect to this, the blue one, like so. And that just leaves the negative from the light to go back out the plug to there. So all we've got to do is solder those things together, and we'll be finished with the electronics and ready to move on to the hard part, which is the different layers that we have to put together. I can't let go of this plug for just a minute though. So any questions? Let me see. Oh, how do I get rid of that thing? There we go. All right. I didn't know I had a drinking game with Joseph, do I? Excuse me. My sinuses are draining in just an uncommonly evil way. All right, so let's connect the wires ready to solder. Now, this is where normally I would pre-solder these things together, but you know what? I'm not going to do that. I'm not going to tin the wires. I'm just going to blob them together. You'll see. It's shocking, but there you go. If I'd if I'd wanted to be an electrician, I'd have been an electrician. But these things work fine. So I don't know why I got solid core wire for these and then plugged them into the plugs, but it's okay. It also seems to work when you get them hooked up right. So I'm sure there's an electrician out there who's just well, he's quit now. He's gone. He doesn't want anything to do with this channel because I'm using solid wire. I don't know why you can't, but I'm sure there's a prohibition against it. Alrighty, so they're wadded together, and then the power of the last two. Another solid wire. I'll put a little loop in it though. There we go. So they're the only three connections, and once these are put together, the whole thing will work, hopefully. And then we can assemble the various filter pieces, filter panels, get them in place, test it, and I'll show you how to do the inserts in case you've never seen them before. And yeah, I think that's going to be just fine. So I'm getting my soldering iron going. There's a little bit of dangerous lead and tin solder. If you don't have one of these, you need to buy one. They are absolutely fantastic. I don't know what they're called. They're for scraping along the edges of things that come out the printer too sharp. They work on metal too. Absolutely beautiful instruments. Highly recommended. Okay, that didn't take long. My soldering iron is already hot as Hades. I'm going to put a little blob of flux paste. No idea why, but yeah, that's what everybody seems to do. So we're going to put a bit of that on each of the connections. It makes the solder go runny, I think. Not really sure, but everybody does it. So there you go. We're doing it. And I have the heat of my soldering iron set to, I have no idea, something quite hot. This was, Laura gave me this soldering iron for Christmas. It's a Schneider, and it's by far the nicest one I've ever owned. I absolutely love it. You see now why I put those shrink wrap sleeves over the wires in the first place? That's so that, yeah, that I can seal these things when I'm done. Notice that what I'm doing, if you're new to this, notice that I'm actually heating up the wires. I'm not just melting the solder, I'm letting the wires melt the solder so that it flows out onto the junction. Otherwise, you can pour solder on it and it just doesn't connect the wires. They need to be hot when you put the solder on. This one's not doing right though. There it is. There we go. That was an absolutely shockingly bad job. My son's an electrician. He wouldn't stand for this. There we go. That looks better. And then one more and we'll be done with the electric part. My flux kind of got in the way there. So when the wires get hot enough, it'll just melt the solder, and that way the solder will flow and the connection will be good. And it won't come undone. I know. Just hold it. Don't tell me. There we go. That's the soldering done. That wasn't too bad. Let's do the shrink wraps while we're at it. I bought a little lighter for this very purpose. So we'll just slip the little piece of shrink wrap right over the joint, so that this is not actually to protect the joint, it's so that nobody can see what bad soldering you did or I did. Do the same on this side. This one's stuck for some reason. Oh, it's got hot glue is holding it down at the other end. There we go. Yep, and then this goes on like this. It's probably a much better way to have done this than using a switch and a plug, but you know, this was what I came up with. And so it's what I did. You are more than welcome to come up with a better strategy for making this, and if you do, share it. by all means. It's it really works for what it's designed to do. This doesn't though. This is driving me nuts. Okay, they're all covered. Now I just set fire to them. See how these things get really tight, and they are lined with glue, which I didn't know. It's kind of like hot glue that melts, and it holds this sleeve right where it is. They're the very devil to get off though, so be sure you're putting it on the right place. That's it. So that's all the electronics done. We ought to plug it in and see if it works. Shall we do that? Let's do that. So I'm plugging it in. Oh, I missed the exciting reveal when I turned it on with the new switch, but there you go. Okay, so that works. Oh, there's one other thing that I like to do is tuck these wires around the side so that they don't get in the way of the levels that are going on top. And I find that a little blob of hot glue does this better than anything else. So bear with me while I put a little blob on a couple of these pieces of wire. This is never coming apart, that's for sure. One down there. We'll put one right there. Yeah, and I've run out of fingers to hold it, but yeah. See the blobs of glue? It doesn't matter where you put them. It'll just, when it dries, it'll hold the wire right there. These things don't get hot. When I made this before, I tested them for 24 hours, and I had them on at 12 volts, and these never got hot. Initially, I had a fan and everything built into the bottom of the case to keep things cool, and that wasn't necessary. All right, one more blob of glue and then we can get on with the rest. I'll just leave this to sit. We're going to need the glue again, so don't turn it off. All right. The reason I'm doing this, by the way, is I want these wires down below this ridge that you can see. If they get above that ridge, they get in the way. And this is the only thing that could get in the way. And I think they're all holding now. Yep. Well, that one isn't, but it's down low enough. There we go. So give me just one more second to hold that in place. Now what we've got to do is cut some perfect circles in, excuse me, 1 second. Oh, God, that is the most nasty thing. Okay, so we've got these cassettes that I showed you earlier on, and nothing needs to go in the retarder cassette because we don't have a retarder for it, so that will just go in the next layer. But before we can do that, there is a permanent cassette that I put on the first layer and have subsequently lost. Where is it? I took it out of there. Did I drop it? Well, let's take it out of another one. There. I don't know what I did with it, but this is the bottom layer. Now, the bottom layer is going to have two things in it. It's going to have a piece of diffusion, a gap, and then a piece of polarizer. Cutting these circles is probably the hardest part of this whole thing. There it is. It was right there in front of my face. Cutting these in perfect circles is very difficult to do without leaving a spot in the middle where your compass was. I've ordered a circle cutter that hasn't arrived yet, and I invented one that I think will probably be better, but that's not finished yet. So this is very important. You need to cut a disc of a diffuser. I'm using vellum here, but you could use mylar. And I've got actually a mylar disc somewhere in one of the other ones. So that goes in the bottom there. And what I've been using is hot glue to put it in. Now, initially I tried to get all the way around it with hot glue, and it just made an absolute horrible mess. So the best way to do it, I found, is just to put 4 blobs. So blob there, a blob there, a blob there. You don't have long once you start doing this. And then a blob there. That's going to be plenty to hold this thing in. because it's not going to be touched. You're not going to be rotating it or moving it. And I just put it in and it sticks pretty much immediately. Wipe away any that gets on that top shelf, because that's where your polarizer's going. There. That's it. That's all there is to it. He says, hoping it stays attached. There. So that's what the business end looks like. If you're good at this kind of thing, you can put a bead of that glue all the way around and stick it in there, but it's overkill. Not necessary. This is buried deep in the thing. Now, here's one thing that I made this mistake twice already today, where I glued in my polarizer having forgotten to take off the covering. If you do that, you have to disassemble everything and start over, because the polarizer doesn't work with that covering still on it. Not completely anyway. Now, you would think that the way to do this would be to put it bent side down like this. There's a piece of that on both sides. You'd think that would be the way to do it. It actually seems to go on better this way because of the fact that it's going to sit right for you for the first blob of glue. And then I'll do the same thing, just four blobs. I'll put them on in different corners though. So a little blob every little bit is all it takes. And then we're just going to drop this in, hold it down for a second, and we'll be done with this layer. There we go. You've got to be fairly speedy with this. Make sure you get it to fit right in the cavity. Those of you who end up getting the kit, I'll have already cut all these for you, so you don't have to mess with it. Okay, so hold them down, maybe smear them a little bit with your fingers if you need to. You don't want to push it so far in that it contacts the diffuser, but look at that. This stuff is probably not the best choice, but it was what I had on hand, the glue. Seems to do a good job. Once this dries, these things aren't coming out. So that's that. I guess you could use Bondic for this, but that would make it a very expensive polarization platform. Okay, so that's it. That's level 1 finished. And it has to go in this way. It's the only way it will fit. It's the only way that I made the thing, is so that that would fit snugly down in there, because it doesn't have to turn. It just stays like that. Level 1 done. Level 2 done. Notice I'm lining up the nubbins so that it won't rotate. That's it with its cassette. If you get a retarder plate, put the retarder filter in there, the wave plate filter in there, and then just drop it in. Next, specimen. Specimen body, nubbins, align the nubbins, drop them in. Slide holder, drop it in, and this turns freely. Last piece is the analyzer, the top retarder. Line up the nubbins, drop it in the slot, and let's pay attention to getting the last piece done. This is the top polarizer. Exactly the same as we just did. Make sure you've cut it to the right size. My goodness, I don't think I did. No, it's pretty close. I think that'll fit. Peel off the 2 layers. I told you this would be fun. It is exciting, isn't it? No? Well, in a minute I'm going to show you probably the coolest piece of equipment that I have acquired of late for my DIY pursuits. And I'll show it to you and how it works. So, layer 2 off, like so. Try not to touch this too much once you get it cut out. You've got some room above this, so it doesn't matter if it bulges up ever so slightly. This piece is too big. This was my fault for not paying attention when I cut it. I'm going to trim it with my Iris scissors. This is on the list to get a nice pair of curved iris scissors because they are ideal for this job. I think it was on this edge that was a bit bulgy, so they cut a lovely circle like that. That now fits. Hot glue, same thing. Blobs at the points of the compass, or anywhere you want to put them, really. Doesn't matter. Doesn't make any difference. And it doesn't take much. The reason I put a fairly decent sized blob on is because if you put on a very, very small blob, it'll dry before you can get back over here to put this on. So that goes right in there. Oh, and if you touch it when it's right out of the heat gun, it can get pretty hot. Hence the name. It's all in the name. All right. That is the last layer you have to do anything to. And that will stay in there beautifully. Now, this one you will be manipulating. You will be moving this one with the tip of a pen or a pencil. So it's good to make sure it's good and properly glued in there. I might have to go back and retrim this because it looks like it's got just a slight, well, yeah, right there. It's not quite fitting. You know, good enough for government work. This should go in with the retarder plate, I mean with the polarizer up. If you put it in with the polarizer, sorry, if you put it in with the polarizer down, like that, then the holes aren't in the right place on the edge. That was just a design problem that I had. Didn't realize it until later. So don't worry about it. Pop it in there like so. Line up the nubbins. And you are officially finished. You just need to put the lid on. Let's grab a slide to put in. I haven't looked at this one. I do hope it's birefringent. So this is how you'd put the slide in. If you were planning on going crazy with this and turning it upside down, it might not be a bad idea to put a drop of hot glue just to hold the slide from overly rotating, well, falling out of the thing if it was upside down. So we'll just put that in there like that. I don't think that would touch it on the underside. No, that'll have clearance. So line up the nubbins, drop in the top polarizer, then put on the lid. The lid is held in place with two of these thumb screws. And you're wondering, hey, Alan, what's those brass things that you're screwing those screws into? That didn't 3D print like that, did it? No, it didn't. These are the inserts that we put in with a soldering iron. I'm going to show you that very, very quickly. So there we are. That's the thing finished. That's all you have to do after you 3D print it. Let's see if it works and if that crystal is birefringent. I hope it is. So we plugged it in, turned it on, and you're thinking, well, it doesn't look birefringent. That's because we have to rotate the polarizer out of phase. So we'll see if it extinguishes properly. You know what? I may have just glued this polarization layer in. Oh man, look at see the crystals coming into view there as we get closer to extinction. That's probably too bright. It is too bright. I'll take a picture of this and show it to you. I do have hot glue that's stuck to the thing. But that's it. That's what you would do. You'd rotate it until you got complete extinction of the light there, and then your crystals would show up. Beautiful. It's actually working. We might look at those under the stereoscope in a minute. There we go. So that's it. And we were done in just enough time. I am going to show you this tool though. Let me turn off my hot glue gun and bring this over. Now, I'll put a better view on so you can see what it is I'm talking about. This is the gizmo. It's a soldering iron on an arm that goes up and down, and you use it for putting inserts into 3D prints, and they go in perfectly straight, which if you've ever tried to do this by hand like I do, they don't go in perfectly straight. They go in perfectly wonky every time. Let me see if I can change this camera angle ever so slightly so that you can see how it works. Let me see, did I guess right? It's gone upside down. That might be the phone. No, I'm very confused now. There we go. Yeah, that'll work. So let me just plug it in. I forgot to do that. All you do is you take the correct sized insert, you drill a hole very slightly larger than you would think you would need. There's a specific size for each size insert. Get your soldering iron on, and then you just gently seat it into the piece. Now I got a piece from something else I'd printed some time ago. It's got holes that don't have inserts in them, and they're flat, so we'll use these. Make sure that your gantry will go down far enough. Mine won't, because I've got a stop in the way, so I'll move the stop down, and I'll loosen up my spring so that I've got... Oh dear, my little spring holder just fell out. Hang on. I don't have the right kind of nuts for this. I just used the ones I had, and yeah, that's not going to work. Don't worry about it. I'll just no, we do need to worry about it, because that needs to be on. All right, just chat amongst yourselves. This is starting to irritate me mightily. There we go. Let me just lower that there. Perfect. Okay, good. That will stop it from going too far, and that'll stop it from going too deep. So there we go. Now let's get an insert. These are all the inserts that I have, all different sizes. I'm going to turn this little soldering iron on. You set the temperature of this according to the kind of plastic you're inserting it into. I'll take one of these quarter 20s because I think the hole's the right size for it. Aren't they beautiful? These are what we're going to insert into our part. No, they're too big for that hole. It's probably an M. These are only M4s. These might be too small. Typical demo. Yeah, they're too small. And I don't think I have any M5s. You know what? We're gonna go with the big one, and I'm just gonna find another part of this that I can sink it into. We'll just pretend that this is the right size. So we will. So there's the piece. This camera angle's not good for this, but yeah, normally you'd put the insert just down inside the hole ever so slightly, and this is the wrong size as well. I'm messing this up. This is an M3 iron, but you know, it's still going to get the thing hot. So you push it down in there, and it will start to get the insert hot, and as it reaches temperature, it'll just sink right down into your plastic. Now this is not going as fast because it's not got as much contact with a small M3 insert. So it just slides right in as it gets hotter, and then when it's finished, now of course it would be flush, but you see it's too long to be flush. because I picked the wrong size. But that's the idea. This keeps it straight when you put it in. That was a disastrous attempt at a demonstration. So I'm going to turn this off and get it out of the way so we can forget about it. There we go. But that tool is amazing. I love it. It only costs $20. So what's the other thing we're doing? If you have not heard or seen any chatter about one of these things, I'll tell you very briefly what it is and what it does. It is a microscope. It's the parts of a microscope that has been dismantled. This is that used to be the focus block, the bit that you would rack up and down with the knobs in order to make the stage go higher and lower. It would normally have sat like that, with the piece coming across the top with the objectives here and the eyepieces here. You can't see any of that because my camera's drifted back to where it was. Hang on. Ugh. Yeah, that'll be better, I think. It may drift again, but... So, here's the deal. To make this work like a stack shot rail, all it needs is a motor and a way to control the motor. Well, I'm going to turn on another light. And I'm going to blow my nose off camera. Oh my goodness. That is just disgusting. So you can see how the rail, my stack shot rail here, moves with a motor, because it has a geared lead screw here that engages with the carriage and moves it a certain distance. I think it's about, what is it, a millimeter for every full rotation of the motor, something like that. The point is, the gearing on this is 10 times finer, so that one rotation of the same motor as this will actually only move the focus block about 100 microns, which is a fraction, obviously, of 1,000 microns. It's a tenth of 1,000 microns, which means every time you take the shortest step you can with this, which is 1 micron, you could be moving your camera only a tenth of a micron with this, which means for high magnification, this is the only way to go. It's a very precision approach to moving your camera in focus stacking. And it's done by the same motor that is on the stack shot, this motor. It's a 200 step, not a precision motor. It's just a 200 step that's capable of micro stepping. This is the same motor, the exact same specifications, different maker. And inside this is a shaft that terminates in a cap, and that cap has a little rubber ring inside it that engages with the fine focus, so that when the motor turns, the fine focus turns. And because these better microscopes like this Olympus don't have they have a separate mechanism for moving the fine focus and the coarse, such that I could move this entire focus block from one end of its travel to the other just using the fine focus. Cheap microscopes, you can only turn the fine focus a little ways and it engages with the coarse focus. But on these, you can do it the whole way. So that makes this an infinitely flexible stacking platform. And it works just exactly as if it were a rail. In fact, what I'm going to do is unplug the connector that it comes with. So I'm unplugging the stack shot, and I'm plugging in the focus block. And I had to make the plug myself because I couldn't find the ones that it actually uses until the other day. But yeah, this works fine. So I plug that in. Now this is connected, and when I do the same thing of moving forward and backward, it moves the microscope focus block. Except because of the gearing inside here, this is moving very, very slowly, but very, very accurately. So there are two things that you need to make if you're going to build one of these, and you'll see from the 3D plans, three things, sorry. The first is this housing. We're out of time. I'm not going to be able to take it off and show it to you, but it's just this plastic housing. You have to print that. You don't have to modify it in any way. It is made for this particular microscope. The other piece is the cap on the inside. And I'll show you. It has a little flat flange in there that attaches the cap to the shaft. The only other thing you need is an adapter plate that attaches to the top of this piece of metal for you to mount your camera on. Also, you need to get your hands on some surgical tubing or some other preload, some other way to provide preload to this to get rid of backlash. I use just a short length of surgical tubing that I didn't know until 2 days ago comes in black. So that goes through your adapter block and over these screws at the bottom. And that will keep constant pressure like gravity would if the thing were upright. Literally, you print this, hold it against the microscope and mark the 4 drill points. Drill it out. I put them in places that they don't touch anything critical inside the focus block. You used a screw of the length that I'll tell you in the documentation, and just you screw the whole thing on, and in doing so the cup sits over the fine focus, and you screw using these 2 screw holes. You put your adapter plate on top, which has a quick release plate for your camera, and Bob's your uncle. This goes through a hole that I put in the adapter, and that stretches the thing so that it doesn't have any backlash. And that's all there is to it. That really is incredibly simple. About the most complicated thing is making these plugs, which you don't have to do, because I did find a company called Vetco, VETCO, that makes these waterproof mini 4-wire connectors. They're just obscenely expensive. They're $8 per connector. These that I would make for you are only $7.95 a piece, but they are more beautiful, and yeah, they work. So that's it, guys. I'm sorry we ran out of time. I really thought that I'd have more time than this to show you the other gadget, but if there are questions about it, I'll show you this next week if we need to take a few minutes just to answer any questions. But yeah, this works absolutely like a charm. I can't believe how good it works with the StackShot controller. Also works just as well with the Wii Macro controller. It would also work with any other microscope focus block that you wanted to use, providing it has continuous focus. So if you have any questions about that, let me know. If you want one of these, if you just want to buy one of these, get in touch with me and I'll think about it. Okay, so yeah, that's it. And I need to blow my nose again, so I'm just going to sign off right now so that you don't have to listen or see that. I will read your comments. I'm sorry I couldn't do it while I was yammering, but yeah, that's it. I'm out of time. What did you think? Any good? Give me a thumbs up, or has David already taken care of threatening you into doing that? Thank you, David. Thank you, Crispy B. What are you doing here? What a pleasure. So glad you made it. Anyway, thank you all for coming. Thank you for bearing with me during this whole DIY thing. I've got so many other projects. Wouldn't it make more sense to have an indentation or bumps on the yellow ring so the slide sits in place and doesn't need to be glued down? It doesn't need to be glued down. It's just that particular print. If you look at the old ones, they have tiny nubbins at the top edge. The slide goes in and you squeeze the ring to drop it in, and when you release it, it holds it firmly. I didn't do that on these because I was in a big hurry to get them printed. But yeah, don't worry, you don't have to put glue on these. You really don't. That was just for me to do the demo. Yeah, and I'll redo the drawings for that so that it'll be just like it was on the other one, which was brilliant. But good point. Your point is well taken. Do fingerprints on any of the optical elements or assembly cause issues with the resulting image? No, they're way out of the focal plane, and I clean them anyway. I mean, I wipe them down, make sure there are no fingerprints or strings of glue or anything on there. But it really doesn't, because you're a centimeter and a half out of the focal plane. So I have never seen a problem with it. Most of these crystals are so bright and angular, you couldn't see anything if you were trying. Okay, guys, thank you very much for coming. It's been a fun project, and we'll be getting back to more normal stuff next week. So, yeah, sorry I didn't get to keep up with the questions today, but if you asked any good ones, I'll cover them when we meet on Tuesday. Don't forget Pazoom on Saturday if you can make it, and that's it. Run out of things to say. Have a great weekend. Stay safe.